Hi to everyone, myself Dr. Dhananjay Rao, working as assistant professor in the Department of Chemistry. Today I am going to teach about liquid fuels and refining of petroleum. Liquid fuels and refining of petroleum. See, in this session I am going to cover these topics. What are the liquid fuels, how you can refining the petroleum, and fractional distillation method. In this session I am going to clear about liquid fuels. What are the liquid fuels, the refining process of petroleum, and the fractional distillation involved in the separation of or refining of the petroleum. First, we are going to learn about liquid fuels. Liquid fuels are the important commercial and domestic fuels used in these days. Liquid fuels are the important commercial and domestic fuels used in these. In these days, we are using these liquid fuels in commercial as well as domestic purpose. Most of these fuels are obtained from the naturally occurring petroleum or crude oil. Most of these liquid fuels are obtained from the naturally occurring petroleum or crude oil. From the petroleum or crude oil, we are getting the liquid fuels. The primary petroleum. What is primary petroleum? See, the petroleum or crude oil nothing but we can call also petroleum. The petroleum or crude oil is dark greenish brown. The color of the petroleum is dark greenish and dark greenish brown color. It contains dark greenish brown color. Viscous oil. The viscosity of the petroleum is more and it found in deep in the earth crust. The petroleum available in the deep in the earth crust. Crude oil is a source of many liquid fuels. This crude oil are liquid petroleum or petroleum. These are the liquid fuels. Okay, many of the liquid fuels are obtained from these crude oil or primary petroleum. Crude oil is also contain impurities like moisture, sulfur, and nitrogen. The crude oil also contain these are the impurities: moisture, sulfur, and nitrogen. The crude oil contain liquid fuels as well as the impurities like moisture, sulfur, and nitrogen. It is a complex mixture of various hydrocarbons from C1 to C35. The crude oil or petroleum contains a mixture of various hydrocarbons. The mixture of various carbons from C1 to C35. In that, the crude oil contains this type of structures. It contains like chain paraffins and cycloalkanes or olefins and aromatics. These are the types of hydrocarbons present in the crude oil or petroleum. The composition of crude oil or petroleum approximately is the composition of crude oil or petroleum is the carbon. The crude oil contain the carbon percentage is 80 to 85 percentage. The carbon percentage is 80 to 85 percentage. Petroleum contain the hydrogen percentage is 10 to 14 percentage. Similarly, it contains the sulfur percentage is 0.1 to 3.5 percentage, and it contains nitrogen percentage is 0.1 to 0.5 percentage. Many of the liquid fuels are obtained from the crude oil or petroleum. Okay, the crude oil or petroleum contains C1 to C35 hydrocarbons like chain paraffins, cycloalkanes, olefins, and aromatic, etc. The composition of the crude oil or petroleum is the crude oil or petroleum contain carbon percentage is 80 to 85 percentage, and hydrogen percentage is 10 to 14 percentage, and sulfur percentage is equal to 0.1 to 3.5 percentage, and it contains nitrogen 0.1 to 0.5 percentage. The crude oil may contain impurities like moisture, sulfur, and nitrogen. See, refining. Before going to refining of the petroleum, we should know about refining. What is meant by refining? See, refining, the process of purification and separation of various fractions. Okay, the process of purification and separation of various fractions present in the petroleum. Okay, the petroleum contains various fractions. Okay, the process of purification of and separation of these fractions in petroleum or crude oil is called refining. By using which method? By using the fraction distillation is called refining of petroleum. By using fraction distillation process, we have to separate or purification of the petroleum. The petroleum contain several fractions. Okay, several fractions present in the petroleum or crude oil. The process of purification and separation of fractions, separation of various fractions present in petroleum or crude oil by using which method? By using fraction distillation method is called refining of petroleum. The process is called refining of petroleum. What is refining of petroleum? The process of purification and separation of various fractions present in the petroleum or crude oil by using fractional distillation method is called the refining of petroleum. The process called refining of petroleum. See, the refining of petroleum is done in different stages. The refining of petroleum can be done in different stages. In the first stage is removal of solid impurities. Removal of solid impurities. See, the petroleum or crude oil contain the solid impurities. How you can remove? See, the first step involved is removal of solid impurities. The crude oil is a mixture of solid, liquid and gaseous substances. The crude oil may contain solid impurities, liquid impurities and gaseous substances. Any may present in the crude or petroleum. This is allowed to stand undisturbed for some time. The crude oil or petroleum should be allowed to stand undisturbed for some time. Allowed to stand undisturbed for some time. Then what happened? When the heavy solid particles, okay, if the crude oil or petroleum contain heavy solid particles present in that crude oil or petroleum, those will be settled down and gases evaporate. If the crude oil contain heavy solid particles in that, okay, if you allow to stand or undisturbed for some time, what happens? The heavy solid particles in the crude oil or petroleum will be settled down. Okay, if any gaseous impurities or gaseous substance present in the petroleum or crude oil will be evaporated. Okay, if you allowed to stand for some time or undisturbed for some time, then what happens? If any heavy solid particles present in the petroleum or crude oil will be settled down, and if any gaseous substances present in the crude oil or petroleum will be evaporated. The superabundant liquid is then centrifuged, wherein the salts get removed. After then, the superabundant liquid, okay, the remaining liquid after separation of the solids and gases, the water, the liquid present is that called superabundant liquid. The superabundant liquid is then centrifuged. Okay, then we have to go for centrifugation process, wherein the solid get removed. Any solid impurities still, if any solid impurities present in that crude oil or superabundant liquid will be separated by using simple centrifugation process. The next step is removal of water. This process is called Cartel's process. Removal of water or Cartel's process. See, the second step involved is removal of water from the petroleum or crude oil. The crude oil obtained from the earth crust is in the form of stable emulsion of oil and brine. Actually, the crude oil obtained from the earth crust. Okay, the obtained crude oil is always in the form of emulsions of oil and brine. Brine nothing but salt of sodium chloride and magnesium, like that. Okay, it is a brine means salts. Okay, the crude oil is available in the form of emulsion with oil and salt. Okay, the emulsion will be in only one phase. Okay, those are in miscible state. Okay, oil and this brine solution both are in miscible state. That is called emulsions. Liquid in liquid is called emulsions. Liquid in liquids called emulsions. The crude oil obtained is in the form of emulsion form. There is no two forms, oil phase and the liquid. The oil phase and this brine liquid phase both are in miscible state. That's why we call emulsions. This forms stable emulsions. So we can't separate this oil and this brine. Those are emulsion form. So those are in same phase, and so those are miscible in form. So we can't separate these by separation method. Okay, this mixture when passed to highly charged electrodes, if you pass this emulsion or oil brine emulsions into the between two highly charged electrodes, what happens if you send these emulsions into two highly charged electrode charges? Okay, what happens? The emulsion will destroy the emulsion films and the colloidal water droplets converted into bigger drops. Okay, if you send this brine solution, the emulsion solution, into a two highly charged electrodes, then what happens? The emulsion will be destroyed. The formation of the emulsion film will be destroyed, and the collided water droplets. What are the droplets? Water droplets present in that emulsion, that will be converted into the bigger drops. Okay, na, the smaller drops are converted into the bigger drops and get separated from the oil. Then these form two phases. So by simple separation, we can separate the oil phase and the water phase by sending these emulsions into the two highly charged electrodes. By sending these emulsions into the two highly charged electrodes. See, in the first step, the removal of solid impurities, what we have to do? We have to allow this crude oil for the undisturbed or for undisturbed for some time. Okay, if you this allowed to the start for undisturbed for some time, then what happens? The heavy solids present in this crude oil or petroleum will be settled down. If the crude oil contain gases, impurities or substance, that will be evaporated. By this simple, the supernatant liquid will be centrifugated. Then the solids will be get removed or separated. In the second process, removal of water or cartels process. In this, what will happen? The crude oil obtained in the earth crust will be in the form of stable emulsions. Oil and these brine solutions are in miscible state and emulsion state. For that, to separate this oil and this brine solutions, for these emulsions can be sent into the two highly charged electrodes. Then what happens? The emulsion will be destroyed and the water droplets, small water droplets, converted into the bigger droplets, and this forms two phases, oil phases and liquid phases. These will be separated by using this removal of water and cartel process. Removal of harmful impurities. In this step, in order to remove sulfur compounds in the crude oil, in order to remove the sulfur compounds or harmful sulfur compounds in the crude oil, it is treated with copper oxide. For the sulfur, we have to add the copper oxide. Then what happens? The sulfur compounds get converted into insoluble copper sulfide. What happens if you add copper oxide to these sulfur molecules present in the crude oil? The sulfur reacts with the copper oxide. It forms the sulfur compounds get converted into the insoluble, okay, the precipitate form of the copper sulfide. It forms copper sulfide precipitates, which can be removed by filtration. Okay, this sulfur forms copper oxide reacts with sulfur. It forms copper sulfide. This copper sulfide is precipitate in form. So this we can be removed by simple filtration. The substances like sodium chloride and magnesium chloride, it is present, will corrode the refining equipment and result in the scale formation. Okay, now if the salts like sodium chloride and magnesium chloride like present in the crude oil, that may result in the scale formation and corrode the equipment. These can be removed by techniques like electrical desalting and dehydration process. By using this process, desalination and dehydration process, we can remove the salts present in this crude oil like NaCl and magnesium chloride salts can be removed by using this process like desalination and dehydration processes. The fractional distillation. What is meant by fractional distillation? Already we refining petroleum, we use the process of fractional distillation. Okay, what is refining? What is refining means the process of purification and separation of various fractions present in the petroleum. The process of purification and separation of various fractions present in the petroleum or crude oil by using fractional distillation process. By using fractional distillation process is called refining of petroleum. Okay, by using fractional distillation process, we can separate and purification of petroleum is done. That process is called refining of petroleum. See, then what is the meant by fractional distillation? How we can do the fractional distillation? How we can separate the petroleum from by using this fractional distillation? Okay, see, crude oil is a mixture of hydrocarbons with specific boiling ranges is called fractions. The crude oil is a mixture of hydrocarbons. Already I have said that the crude oil contains C1 to C35 carbon chains. Different types of carbon chains are present in this crude oil. Okay, the crude oil is a mixture of hydrocarbons with specific boiling ranges. Okay, na different boiling points contain this mixture. Okay, the crude oil is a mixture of hydrocarbons. Different hydrocarbons contain different types of boiling points. Okay, different type of specific boiling ranges. So those are called fractions. Okay, na different fractions are called different types of boiling ranges are arranged. Those are called fractions. Crude oil is a mixture of hydrocarbons with specific boiling ranges. Okay, na the hydrocarbons which contain specific boiling ranges, those are called fractions. Okay, these fractions can be separated by using fractional distillation column. Thus, these fractions, okay, na these different boiling ranges contain fractions can be separated by using fractional distillation column. By using fractional distillation column. Heating of crude oil around 400 degrees centigrade in iron retard. Okay, heating of, see the how we can perform the refining of petroleum. See, heating of crude oil or petroleum. Okay, both are same. Heating of crude oil around 400 degrees centigrade in iron retard. First, in iron retard, we have to take the crude oil. We have to heat it 400 degree centigrade. It produces a hard vapor which is allowed to pass through the fractioning column. Then what happens if you heat the crude oil? The crude oil contains different types of fractions. Okay, these liquid converted into the vapors. Okay, na by at 400 degrees centigrade, the liquid form converted into the hot vapors. Then we have to allow these vapors into a fractionating column. The fractionating column. Then the vapors will be allowed into the fractionating column. It is a tall cylinder tower containing a number of horizontal stainless trays. See, this is the fractional distillation column of petroleum column. Okay, this is the process of refining petroleum. This is furnace. Okay, this is furnace. This is a iron container. Okay, in the furnace we have to supply at 400 degrees centigrade. This is the contained crude oil. We have to supply or heat at 400 degrees centigrade. What happens? This is the iron container. This is the iron container. See what he said? It is a tall cylindrical tower containing a number of horizontal stainless trays. See, this is a vertical. See, it is a cylinder tower containing a number of horizontal stainless steel. This is a vertical tower. Okay, na? This is the vertical tower, iron tower. In this horizontal trays, these are the horizontal trays present in this iron container. Okay. A number of horizontal stainless trays. Those are stainless trays at short distance and provided with a small chimney covered with a loose cap. See, this is the structure of refining petroleum process structure. See, this is container. In the container we have to heat at 400 degrees centigrade. Okay, na? This is the iron container. This is the iron container. It contains horizontally separated the horizontally separated stainless trays. These are the trays. These are the trays present in the iron container. These are separated in short distance. These horizontal trays are separated by the short distance. This horizontal tray, okay, na horizontal tray contain chimney. Okay, every horizontal tray contain chimneys. Okay, na these chimneys allow vapors into the upper container. Okay, na this allow the vapors into this upper or above container. Okay, and it will not allow the liquid form, the condensed liquid into this again into the, it will not allow the condensed liquid into this chamber. Okay, only the chimney allow the vapors into the outer body. Okay, na this chimney allow the vapors into the outer body, and it will not allow the condensed vapor into this same body. It will not allow the condensed vapor or liquid drops into this same body. This is the process involved in the chimney and the fractional distillation process. See, it is a tall cylindrical tower. It is a tall cylindrical tower containing a number of horizontal stainless trays. The horizontal stainless trays are present in the tall cylinder. at short distance, and it is provided with a small chimney. Okay, every this tray, horizontal tray, contain chimney covered with a loose cap. It is covered with a loose cap. As the vapors go up, they get cooled gradually. Okay, what happens? See, this we are applying 400 degree centigrade temperature. All the liquid crude oil or petroleum converted into into vapor state. Okay, na, the liquid converted into the vapor state at 400 degree centigrade. All the vapors entered into this long or okay, all the liquids entered into the tall cylindrical tower. Okay, na? After these vapors entered in this cylinder, okay, these vapors are going up. And at some point, cool down. This will be get cooled down. Okay, this will be get cooled down. Then the vapor converted into the liquid. At that we can separate those liquid. This process called distillation of petroleum. As the vapors go, they get cooled gradually and fractional condensation takes place. As the vapors go up, they get cooled. Okay, na? As the vapors go up, they cooled gradually and fractional condensation takes place. At different temperatures, the condensation takes place. Higher boiling fractions condenses first. Okay, na? In that crude oil or petroleum, the higher boiling fractions, the fractions which contain higher boiling point, those are okay, na, those are condensed first. Those fractions will be condensed first, and those will be collected first, and later the lower boiling fractions. After last, the lower boiling fractions, the crude oil which contain the lower boiling fractions, those will be separated. In the fractional distillation of petroleum, refining of petroleum, the fractions which contain higher boiling point, those will be condensed first and separated first, and the fractions which contain lower boiling point, those will be collected lastly. To understand the fractional distillation process, see, these are the steps involved in the fractional distillation process. See, let's say one container contain fraction A and fraction B. One container contain two fractions. One is A, other one is B. Okay, the case 1. Let the boiling point of B is 60 degrees centigrade. The boiling point of A is 60 degrees centigrade, and the boiling point of A is 100 degrees centigrade. The boiling point of B is 60 degrees centigrade. The boiling point of A is 100 degrees centigrade. Okay, what is boiling point? The boiling point nothing but the temperature at which liquid converted into vapor. That point is called, the temperature is called boiling point of that vapor. Okay, that liquid. Say the boiling point of B, 60 degrees centigrade. Take one container. Let's say A and B, two fractions are there. That the fraction B contain the boiling point 60 degrees centigrade. The fraction A contain 100 degrees centigrade. Okay, let case 1. Okay, we heat at 40 degrees centigrade. At 40 degrees centigrade, if you heat these two fractions, what happens? We are supplying 40 degrees centigrade, but the boiling point of B fraction is 60 degrees centigrade. The boiling point of A fraction is 100 degree centigrade, but we are supplying only 40 degree centigrade. Okay, see, both A and B both are in liquid state. Because why? Because we are supplying 40 degrees centigrade. We are not supplying 60 degrees centigrade or 100 degrees centigrade. We are applying less than that of those boiling points, that is 40 degree centigrade. So there is no possibility of this liquid A and B fractions converted into the vapor. This heating is not sufficient to liquid convert to vapor. Okay, so both A and B are in liquid state at 40 degree centigrade if you supply. Okay, if you take case 2, in the case 2, if you heat this crude oil or these fractions A and B at 70 degrees centigrade, what happens? We know already the boiling point of A is 100 degrees centigrade, the boiling point B are 60 degrees centigrade. In this, what happens if you heat 70 degrees centigrade? What happens? The B contain the boiling point 60 degree centigrade. But we are supplying the temperature 70 degrees centigrade, more than that of this B. Okay, na? The boiling point of B is 60 degrees centigrade. Okay, we are supplying 70 degrees centigrade heat, but A contain 100 degrees centigrade boiling point. Okay, so in this, first we are taken liquid molecules, liquid fractions A and B are in liquid forms. Okay, we are supplying 70 degrees centigrade. What happens? The B contain the boiling point 60 degrees centigrade. We are applying the temperature more than the top. This we are supplying the temperature more than the top. This 60 degrees centigrade. Okay, we are supplying 70 degrees centigrade. So this B, okay, na, the B fraction will be converted into liquid to vapor. Liquid into vapor at 70 degrees centigrade. Means the A is in still liquid form. B will undergo vaporization. The B fraction will undergo vaporization. Because why? Because we are supplying the temperature more than the top this boiling point, the B fraction boiling point. So in this case, the A will be in liquid form, the B will be in vapor form. In the case 3 what happens? We are heating at 120 degree centigrade. Okay, in case 3 we are heating 120 degree centigrade. What happens? The boiling point of B is 60 degree centigrade and the boiling point of A is 100 degree centigrade. We are supplying 120 degree centigrade. What happens? We are supplying this temperature, this heat more than the top boiling points of A and B. So this A and B both will undergo vaporization. This both A and B will undergo vaporization at 120 degree centigrade. So A and B, these two are in vapor form. See, in case 1, if you supply the temperature less than that of these two boiling points, okay, these two boiling points, then these two fractions are in liquid form. In case 2, what happens? We are applying 70 degrees centigrade. So in this case, the B will be converted into vapor form and the A will be remains in solid liquid form. In case 3, we are applying 120 degrees centigrade. So we are applying heating more than that of these boiling points, 60 and 100 degrees centigrade. So the two fractions A and B are in vapor form in case 3. Okay. See here. One more design. See, in this A and B are two fractions. A and B are two fractions. The A boiling point is 100 degrees centigrade and B boiling is 60 degrees centigrade. In the fractional distillation, what we have to do? First we have to supply. Okay, na? We have to supply heat more than that of these two boiling points. Okay, that's why we are applying 150 degrees centigrade temperature in this container. What happens? The boiling point of A is 100 degrees centigrade. The boiling point of B is 60 degrees centigrade. So both boiling points are less than that of this temperature. So these two liquids, A fraction and B fraction, will undergo vaporization. These two will undergo vaporization. Okay. These two liquids converted into a vapor. These two enters into a fraction, this container. Okay, na? These two A and B converted into vapor and enters into this container, above container. Okay, in this container we are maintaining the temperature 80 degree centigrade. We are maintaining temperature how much? 80 degree centigrade. See, at 80 degree centigrade what happens? The boiling point of A is 100 degree centigrade. Okay, the boiling point of C is 60 degree centigrade. But in this container, okay, in this chamber, how much temperature we are maintaining? Just we are maintaining 80 degree centigrade. In this form, A and B are in vapor form first. Okay, na? But we are maintaining the temperature 80 degree centigrade in this chamber. Okay, na? Then what happens? See, the boiling point of A is 100 degree centigrade. The boiling point of B is 60 degree centigrade. So here we are maintaining 80 degree centigrade. Means the A will be converted into vapor into the liquid because there is no sufficient heat, okay, na, to maintain vapor state. That's why these vapors A converted into the liquid form. But B still in B boiling point is 60 degree centigrade, but we are supplying 80 degree centigrade. So the B fraction will be in vapor form. The A will be in liquid form. Okay, these two vapors convert in these two vapors. A convert into liquid, but B will be in gaseous form or vapor form. Okay, this form A convert into the liquid. The formed liquid will be collected at this stage. Okay, now these vapors, the B, okay, now B vapors present in this chamber. This will be going through this chamber. Okay, now this going into this chamber. Here you are maintaining 50 degrees centigrade. Okay, here maintaining 60 degree centigrade. Initially, these vapors, the B vapors entered into this chamber. The boiling point of B is 60 degree centigrade, but we are supplying only 50 degree centigrade. So these vapors, the fraction B vapors convert into the liquid because the boiling point of B is 60 degree centigrade, but we are supplying only 50 degree centigrade. So these entered vapors, okay na, these vapors will be converted into the liquid form. Those liquid will be separated in this chamber. This process is called fractional distillation. Based on this boiling point, we have separated these fractions that called is fractional distillation process. The crude oil is a mixture of hydrocarbons with specific boiling ranges called fractions. Crude oil is a mixture of hydrocarbons with specific boiling ranges. Okay, those are called fractions. Based on their boiling point, different fractions are separated. Based on their boiling point, different fractions are separated at different places in vertical column. In this vertical column, okay na, different fractions will be converted into the liquid based on their boiling points. The higher boiling point having fractions contains firstly the liquid, the crude oil which contain the fraction which contain higher boiling point. Okay na, the liquid which contain higher boiling point, those will be condensed first and collected at the bottom of the tower. Those which contain higher boiling point fractions, those will be condensed first and those will be separated first from the bottom of the tower. Okay, and the lowest boiling point having fractions are collected as gases. In the crude oil which contain the fraction lowest boiling point, which contain the fraction lower boiling point, those will be collected as a gaseous. Okay, na? Those will be collected as a gaseous at top of the tower. Top of the tower, we can collect the lower boiling point fractions or gases. Here, bottom of the container, we can collect the higher boiling point fractions. Okay, this is the diagram of the refining petroleum. See, in this fractional distillation of refining of petroleum, we can separate first heavy oil. Means the heavy oil contain high boiling point. Okay, this will be separated at the bottom of the container. Then next we can separate lubricant oil, then diesel, then kerosene, naphtha, gasoline or petroleum ether. Okay na, these are okay na. This is high in boiling point. This is lower in boiling point. The lower boiling point fractions will be collected at the top of the container. The fractions which contain high boiling point, those will be collected at the bottom of the container. See, these are the properties and uses of fractions of petroleum. See, the petroleum gas, okay na, the petroleum gas contain the boiling point is less than 30 degrees centigrade. The boiling point of petroleum gas is less than 30 degrees centigrade. It contains the composition C1 to C4. It contains the composition C1 to C4. Okay na. It can be used for the petroleum gas is change into liquid under pressure, used as a household fuel, LPG. Okay na. In the LPG gases we use the petroleum gas. The petroleum gas is changed into the liquid form by applying pressure. Okay, that will be used in the household purposes. The next fraction is petroleum ether. The next fraction is petroleum ether. The boiling point of this petroleum ether is 30 to 70 degree centigrade. Okay na? It contains fractions C5 to C7. The composition of this petroleum ether is that it contains C5 to C7 carbons. It can be used for the solvent. As a solvent purpose, we can use the petroleum ether. The next one is gasoline or petrol. The gasoline or petrol. This fraction, it contains the boiling point 40 to 120 degree centigrade. The petrol contains the boiling point 40 to 120 degree centigrade. It contains composition C5 to C9. It contains the composition C5 to C9. It can be used for the solvent and in dry cleaning purpose we can use the petroleum or petrol. Okay. Naphtha. The next fraction is naphtha. It contains the boiling point range 120 to 180 degree centigrade. It contains the composition C9 to C10. Okay, it can be used for the solvent in paints as a varnishes and in dry cleaning purpose we can use the naphtha. Okay, kerosene. The kerosene boiling point is 180 to 250 degree centigrade. The kerosene boiling point is 180 to 250 degree centigrade. It contains the composition C10 to C16. C10 to C16. As household fuel in pressure stoves and lanterns and Petromax lamps, extra, these can be used as a solvent in these cases. Then diesel oil. Okay na, diesel oil, it contain the boiling point range 250 to 320 degrees centigrade. Okay, it contains the composition C10 to C19 as a diesel engine fuel. It can be acts as a fuel in case of diesel engine. Heavy oil. The heavy oil contain the boiling point range is 320 to 400 degrees centigrade. It contains the composition C70 to C17 to C30. It can be used for the getting high quality petrol by cracking. Getting high quality petrol by cracking. Okay, it can be used for getting the high quality petrol. Okay, these are the fractions present in the petroleum. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.